So we're going to go ahead and look at notes 1-4, and I'm on page 26. Nope, page 25. Back one page. So this is page 25. And I like this solve and discuss it. So let's go ahead and look at it. It says Matt and his dad are building a tree house. They buy enough flooring material to cover the area of 36 square feet. What are the possible dimensions of the floor? So I'm big on drawing pictures on these. So if we draw a picture of the floor, we know it's what we call, this is called a 2D shape. It has two dimensions. It has a length and it has a width. Okay, and it also is asking for the area, and so it's important for us to know that the area of this floor would be length times width. And so if this whole area, if I were to shade it in, if this whole area equaled 36 square feet, that's the answer. What could be some possible lengths and widths? What two numbers could multiply together to get us a length, or to get us an area of 36? So length times width to get 36. We'll talk a little bit more about that in class. Remember, whatever I write down on my paper, I want you to please write down on your paper. Okay? So we'll come back to that problem in class. We're going to go ahead and jump right into the lesson. So let's look at 1-4. We're still looking at 1-4, I should say. Page 26. Okay, and the essential question here is, how do you evaluate cube roots and square roots? So we will definitely be talking about what a cube root is and a square root is. So it says evaluate cube roots to solve problems. We've got a birdhouse here. What's a cube? Let's talk about what a cube is, a perfect cube. Okay, a perfect cube is when we have all three sides of a 3D shape. This is a 3D shape. And all three of those sides are the exact same. It's a 3D square is what I would like to call it. A square we know is 2D. Okay, so a perfect cube is when all those sides are the exact same. So I talked in class yesterday that if we had the opposite of add, it would be subtract. The opposite of multiply is divide, or the inverse operations. So when we have a flat shape, a 2D shape, the opposite of squaring a number is taking the square root. Well, when we have this 3D shape and we're finding volume here, the opposite of cubing a number, or to the third power, would be the cube root. And so you can see here that they found the cube root of 216. So it's asking what would be the value, and the value here would be 6. Because if you take on your calculator and do 6 times 6 times 6, you will get 216. Okay? So whenever we're thinking volume and we're looking at cubic feet, we're thinking of our 3D shape. Okay? So let's look at the try it. A cube-shaped art sculpture has a volume of 64 cubic feet. What is the length of the edge of the cube? Well, we have to ask ourselves, what times what is going to get us 64? Okay, and we made a chart in our room for our square roots. We'll make a chart in our room for our cube roots as well. So let's think about this. Well, 1 times 1 times 1. Is that going to get us 64? No. Let's think about 2. 2 times 2 is 4. Times 2 is 8. That's not 64 either. What about 3? 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So that's not 64 either. 4 times 4 times 4. Well, 4 times 4 times 4. 4 times 4 is 16. Times 4 is 64. So the cube root of 64 is the value of 4 feet, or 4 for this example. I will show you how to type this in on your calculator when we come to class. There is a way to type it in. Okay, let's go ahead and go to our next slide here and we'll look at some more examples. Just found this answer. It was right here. 3 times 3 times. So on example 2, we have to be really careful because when we evaluate perfect cubes and perfect squares, we have to know which one we're evaluating here. Okay, so I can tell you that the cubes are when you have a 3. So this would be a cube because it's taking the cube root, meaning that 3 is what we actually call the index. This would be a perfect square because there is no index. It's taking the square root. That square root value actually would be the number 2. This is a square because that value is 2, asking for what 2 numbers are going to get us that radicand. And then this last one would be a perfect cube because it has this index of what we call that 3. Okay, so when we're looking at these, we have to know which one we're actually evaluating. So let's look down at the try it here. This one is saying it's got the 3, so it's saying I need 3 numbers that multiply together to get me 27. And if you remember from our last slide, so 3 times 3 times 3 gets me that 27. So your answer to this is just 3. Let's think of square root. What 2 numbers get me 25? Well, 5 times 5 gets me 25, so my answer for this one is 5. The square root of 25 is 5. It's a perfect square. Perfect meaning that we're getting these whole numbers. Square root of 81 means I just need 2 numbers. What 2 numbers get me 81? Well, 9 times 9 does. So the square root of 81, 81 is a perfect square. The square root is 9. And last, we need 3 values that get me the value of 1, and it's just going to be the 1. The cube root of 1 is just 1. So again, I will show you how we can type these in, but we have to be able to determine, am I looking at a perfect square or a perfect cube? Square is a flat 2D shape. Cube is a 3D shape, all sides equal. So here on example 3, it says evaluate square roots to solve problems. So what they're talking about here is that you have this cork board in your locker, and they're telling you the area. So area, we need to know area equals length times width. So it's a 2D shape. So if the whole thing's 144, they want to know what are the side lengths, because it's a square, that means all the sides are the same. And they just took the square root and got 12. Okay. Let's go ahead and look at the try it here. It says Emily wants to buy a tablecloth to cover a square card table. She knows the tablecloth has an area, that means it's flat 2D shape, of 9. The whole area is 9 square feet. What are the minimum dimensions of that tablecloth that Emily needs? Well, if we take the square root of 9, we're getting 3 by 3. So our value here is 3. It is 3 feet by 3 feet would be the size of the tablecloth. This was a square root because it was flat. Remember, a square root, we don't have, this is called our index, and our index is 2. It's not written. That's okay, but it just means 2. But not least, we always like to look at that key concept box, and so I just want to remind you that the difference, we have inverse operations, and the difference between these two is this first one, the cube root of a number, is when you're going to be finding volume. Let's go ahead and write that down. And it's for a 3D shape. My 3D shape's not perfect there, but we're talking about a 3D shape, 3D cube. Okay? When we're talking about a square root, we are talking about area. And of a 2D shape, meaning we have a length and a width. It's a flat shape. So we know the difference between if they're asking for volume, it means cube root. If they're asking for area, it means square root, flat 2D shape. That's all I've got. Have a great day, and we'll practice these in class.